I'll quickly run this. Estimation of speed. I'll do estimate equation. You go. Now, do you know what I'm going to do in the later? But anatomy, nutrition, or.
No, it is a data actually.
Oh. Because many times when we because data needed to be clean, that will take time. Yeah. Because if things are not coded in one category, but like 1, 2, 3, 4 category labels that will be coded in a particular way, and that. So the purpose of this form is to run an integration, nothing we can interpret. So might as well do something purely random. Okay. So the way all of you start integration with easy, right? Yeah. So what we are going to do is P is my y variable, P is the constant, X is the income, and then gender is the other. And this scroll down and go to binary. Now what we have is we have Logit Probit and extreme value. Okay. I will not be doing extreme value. I will briefly talk about Probit. I am going to do about Logit. So since I will not be doing extreme value, briefly talk about Probit. It's a good idea to tell you what needs to work. Logic is a particular universe. We enter the now saying that we are imposing an assumption which is likely for x factor. It is power in the once we impose a logistic equation assumption, it becomes a dualistic. On the other hand, without imposing that, we could have imposed some other equation, some other assumption in the probability distribution. We could have imposed, we could have imposed models of the data. Then also we get some kind of nonlinear. If we do that, that will be problem. So that is the topic that we need to want. And many a time, what we have, the third one, is that really what we are trying to look at is the normal distribution of everything. We are looking at the bell curve distribution. And it is entirely possible that the extreme values of the tail do not appear in the observation. So what do I mean? In these houses, when we do a sample, we may not sample anyone who has got more than 1 crore rupee annual income. There could be some such a not happening. We have not even sampled anybody who was much below poverty line. 2,000 rupees or even say that. We might have got that. Because we got random samples, we got people who have minimum income of 1 lakh, maximum income of 38 lakh. These are the extreme areas. In your usual events, you will not be able to capture that. But for how to look at an exchange rate, can I different the probability distribution? That's the exchange rate. Again, that's something you cannot do. We also need to learn. So I will take this and then I'll evaluate the logic. And that's the output. First step and easy interpretation of the output. This is CX and gender. Okay. Notice the usual, if I did not do logic, if I did some other equation, ignoring that kind of probability, we will have got something like an R square. You don't have an R square or an angular square. It's something called a maximum R square. But you don't have a singular R square. Why do we have a singular R square? If you remember when we started the class, we were saying what things an R square needs to compare those scatter points to those decayed lines. That did not depend upon whether the line was curved or the line is straight. The still you observe are those only one and the zero. Whether the curve is fixed line like this or it is straight line, it still does not make any sense to compare an R square. Because your observed load is 1 and 0, your prediction, irrespective of linear probability model or logic model, will be between 0 and 1. So therefore R square is not a target. People will say, quite hard to not report out. We will nonetheless have to take a call whether this model is good or bad. That's it says that this is a constant. Okay. Cost is what is minus 2.987. This is the x, so which means this says that however this is not revenue is getting greater, right? So income doesn't come to be important. And without the two gender incentives, what appears is that the domination for gender policy, one were made, zero were female, which means if the household gets into men, more likely to buy a house than household gets into female. But it is not that if you are a household into men, you are more likely to buy 2.5% revenue. Because it's a non-linear probability model. What you have is, even wherever value you are, if you are a male, the marginal probability is not just 2.65, which is the OLS. OLS case, this is nothing but a DY case. DY case in this case will not be that constant value. The actual is as 1 minus. It will depend upon the probability and 1 minus. But this is what we get. Purely random model. If I don't have a model, very power or anything. So let's do something. Let's figure out that how good is this integration or how good is Logit. So we cannot look at the R square. There is a factor in R square. Okay. So we will people try to look at the factor in R square, but I don't prefer to go the factor in R square because I prefer to go the first principle. And there is a way of comparing with a good model at that. That's where we go. That's where we go. So when we go about doing this, I think I might be trying to do it. You can come watch. There was this concordant graph. You know what is it called? The 0.5.
Is it estimate or option?
After that, is concordant graph.
Yeah, I think those are these. Yeah.
Okay. So
Stats. I think you have to press the stats.
sorry, I just do it once more. In expression, what did we do?
P is equal to
P less than
gender.
gender. And then we done logic. This is our solution. Then I have now the next step is how to interpret, how to do the model. So I go to view, I go to the expectation prediction table. And there is a default cutoff for 0.5, where the cursor is reached. I will not discuss 0.5 in the morning class. We'll come to that later. And I can finish it and see what I do. First, I know it's difficult, but do not look at the lower portion now. Do not look at this portion now. The focus only on this side. Focus only on this. And let's see what it is trying to say. So what we have 29 values which were zeros of P and 11 values of 1. That's what you understand. 29 zeros and 11 zeros. Okay. So that is what. So now the model did some fitting. Let's say because the bigger zeros that are constant, there is a bigger one, 2.67 etc. There is some fitting. And for each of the 40 observations, calculated related probability. The cutoff, the unbiased cutoff we took was 0.5. And that was what was being used. So now it is matching the following. Anything which is predicted probability is greater than 0.5, it is matching with actual observed frequency of 1. Anything which is predicting less than 0.5 is matching with an actual frequency of 0. Now there are two types of error that can. Very obvious. First is the predicted to be greater than 0.5, but the actual is, or you predicted it to be less than 0.5, the actual is 1. So whether whichever you want to call type 1, type 2 error, it will make it. But these are two kinds of error. On the other hand, there are two kinds of accuracy issues. You predicted it as 0.5 and the actual is 1, then it is kind of perfectly matched. Predicted it as 0.5 and the actual is 3. That's also perfectly matched. We are not the aspect doesn't make any sense. Because the predicted and that how far is the predicted from the actual, that doesn't make any sense. That makes sense. What actually makes sense is the component and the picture is greater than 0.5, this is 1 also. We cannot compare the 0.6 and 0.51. The 0.6 should be closer to 1 than 0.51. So what we are getting is only 1. So you might as well make anything about 0.5 and actually 1, anything less than 0.5 and nothing. This table is decided. So what is it trying to do? So this is saying, okay, so in estimated, we have this dependent equal to 0 and dependent equal to 1. So how many have been predicted to this? How many have been predicted to be equal to 0? We have predicted 29 to be equal to 0. Okay? And we have so we have system to be equal to 0. And the actual was 729 0. So 100% accuracy. However, our model also ended up predicting the remaining level also. The dependent one, they were ended up predicting that equal to 0. Which means it got 29 accurate. It got 11 wrong. So this TBF or this model, what have we done? If we have only 40 observations, all of them, then instead of low probability of bias, it can already got some right and got some wrong. A better model, or a best possible model would be, which gets 100% accuracy here, as well as 100% accuracy here. What has this model got done? It got 100% accuracy here. It got a 0% accuracy. It's a very big, it normally doesn't happen, but not still doesn't happen. So there's nothing actually. This is the happen. Now, how good is this model? The way to find out how good this model is, to find out what is the percentage of things is correct. Because 72.5%. This is from the usual thing. So 72.5% correct. Well, how many are doing the correct? 20 out of 40, 20 out of 40. But if it's a time when we kind of uniform, we kind of take a very easy form. And this is because of the real example, we get a very low. Then is this a good model? What is an answer? Have we thought in terms of 1 square? What would be an answer for this model? It is 0.75. If 175 is good, what do you think? Because when you run a real life data, they might get answer more than 1.4. But you want 175. It's a great model, because you will go all over. But if you want it this time, suppose we did not do any logic regression. So you gave me money to run logic regression, I went, came back after 1 day, I cannot do the model which calls everybody good, or nobody is unlikely to buy it. How good are this model? Is it completely bogus? Yes, no. Because when I say that nobody will buy a house, I would have predicted activity within it. Meaning to differ by a house, these are kind of predicted. I have a later system, which is by the way what the model has done. So a default model which calls everybody good or everybody bad will by definition have some level of at least 50%. No, it depends upon how many.
At least 50% in the binary model. If you have a model.
At least 50% because depending upon the it will take the higher one. So a default model would be actually 52.5%. Okay? Okay, let's just take the example because the default that this model is coming into this. So let me drop that variable and redone the variable and let's see how it goes. So suppose now this is what we get to see and later.
Maybe you should keep income as a variable. Maybe you should keep income and remove. Because gender is also a 1 0, no? It's a.
No, but that will matter.
Change the income number.
That will go back and change it. Let's see only
Yes. You.
was it logic? Logic. Because it is purely random. You can't have it. After created random, so it does not really very important. The main actual data, which has like some sense to put here, because it is even random in the industrial data, whatever I actually is not going to get in. Okay, it belongs to the equation, how we so a default probability, a default model would change at least 50% actually. So therefore, whatever model which we propose is a good model will only get improvement over and above. Had this been something like a 94% or 85%, which means, if we had got some, instead of this 11, we got something like 5 years, 6 years, which means you have got more accurate prediction, that is very improvement over the default model. Default model will also be 16.5%, and the actual and the latest model is 85%, then you can say that indeed what our model is doing is 12.5%. Of course, we have a problem, because if the default probability model is 72%, then the best incremental prediction mutual model can be only 20%. Not more than that. So it is not very tricky to judge whether this model is good compared to the bad, because you compare with the default model. You should not get carried away by the number 72.5. Nor should you get carried away by the number which is 0 out here. It is nothing to a total gain star. A total gain star would have been the prediction of this minus this time it is 0 out here. But had this been 80%, you would have got a 7.5%. So you should not get carried away that this number is high. You should not get depressed that this number is low. So this number could be low because if your default prediction model predicts about 72.5%, then you cannot expect a whole lot of improvement than that. Some marginal improvement that could be 7.5%. So the first order of thing which we do in terms of interpreting opposite the logic model is precisely the fact that you do not look at outside, you find out how many of them are incorrectly. And you look at both the type 1 and type 2 errors, how many of them your predicted than 0.5 actually goes to 1, how many of the predicted less than 0.5 goes actually to 2. That is a cutoff coefficient 0.5. Then, how good is the model? We compare it with a base model, which is called a constant probability, the trivial model, which picks up, you just want everybody to what everybody does and see how accurate it is. It makes a comparison, and then the marginal basis you have, the marginal or the percentage gain, this is the percentage gain which you have, that is how good is the trivial model. So that is just about the interpretation, which we do in terms of your research. Where we don't choose our item, we are stupid guys, we just choose the numbers and then do it. But it is not practical, we are doing it. Yeah.
Is this something that how we define our 0, 1, something to figure?
No. But we want it. So now,
We have, if our model predicts 29 as correctly and 11 incorrectly, and if we say that it's a model, if we interpret our model in terms of those 11 incorrectly predicted observations, then our model comes out to be bogus. So how are we defining?
we will get there. So we will get there, but not directly. I will address the special issue rating now, and then we will talk about that changing that constant. But I will address the second question which you were interested. So far, the model was about predicting the probability of houses to be buying. Suppose the model was not about buying houses. The model was about how effective this drug on a patient. What are the observations? Drug is administered or not on a particular patient. And what is the likelihood as the patient recovers within 1 month or 24 hours? I don't know. 1 month.
Placebo versus the actual effectiveness.
Right?
Placebo. Like you.
No. That is a different experience. So, this is like a person is not in coma, but there is no one that is administered. You are administering it. 30% is when I know I have been administered something, so I automatically try to get better. So the person is not in coma, but there is no one that is administered. So out of the 40 individuals you have administered the drug. Okay? Let's say to all with unmedicated, they are administered to all with something. And what you are finding is that how many of them are recovered in 24 hours and how many of them are not recovered in 24 hours. So, what has actually happened is, there are 29 individuals who recover in 24 hours. 11 of them did not recover in 24 hours. Let's say 8 of them recovered within 48 hours. Okay. That's it. 1 recovered within 72 hours. That's it. 2 of them done. That's 124 is recovered. 8 in 48. 1 in 72 and 2 of them. That's the data. Your recovery is 1 within 24 hours, not recovery is another situation. Then the chance model prediction is a very simple question. Statistically, this is good. Or let it go to the other extreme. Suppose the incidence is 87%. How do we get the 87%? Let's say we take out this 29. And here we also get 7. Let's say we get 4. So we get 4 out there and 7 out. If it all recover and correctly predicted, out of the 11 which is not recovered, you could correctly predict that it is not 24. So that's the overall model will be something like 87. Now that's the technique. Oh yeah, so what? 29 plus 7 is 30. That's the 90%. Now you guys will take it all on this one. It would not look like as a researcher, what are the results? 90%. Practically it matters a lot. Because what matters is what are you being able to predict correctly. Instead of good because the prediction was recovering correctly, what should we call a drug good which can predict things going quite wrong. Which means what the 90% done that is trying to do, you administer it with 0.9, okay, people will be okay. With 0.9 or with 0.1, people will not be okay. If that is what you want, or you would want what you would want is that whoever says that is going to be not recovering from this, they are indeed will not recover. If you say somebody recovering, the chance that that person also not recover. Do you want to conserve the effect of the drug, or do you want to not conserve it? That is the scientific choice which people will do. The math never will do. Math is the math. So indeed, the model, we should possibly compromise on the following, that is just something wrong out here. If we say recovery may also say, no, it's not 24 hours, but I don't call it as recovery. And instead, it doesn't miss out a single person who has died. That model can be probably far more accurate than a model which predicts everybody that you are going to get well and misses out on something like that. This is purely based on the problem solution. Nothing changes in the relation. Absolutely nothing. Same relation. Except that what we now do is we are changing the cutoff from 0.5 to maybe 0.2 or 0.7. So that what we are going to say is, earlier 0.5 and above would have said recovered. We will only see the charging effective if the penetration was to be greater than 0.2. If a patient is not recovering with greater than 0.9, we are not going to call that patient recovered. In unbiased model, anybody is half channel recovery because they are recovered. And then the dark channel commercial recovery. But now we can make strict separation that we only call this the dark channel recovered if the patient recovers with 0.9. If we use that, what will happen? Some of this will become, we start conversion. Some of this will now start increasing. What you will be able to now capture is anybody who is not supposed to recover and you are able to capture that. All the people are supposed to recover, you will lose out on something. The area which you commit in this part is dangerous. What you do not want in the market is a graph where